The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you guys are in the country. It's Mark from SolidCAM. We'll be doing today's SolidCAM Live today, half-hour free training during this pandemic period. And with me, as always, is our buddy Kevin Rankle. How you doing, Kevin?
Hey, good.
I was thinking what we could do is maybe a little contest. Is I need a better opening than just that. So send your ideas to that as well. I'm thinking maybe not. Maybe we'll do it. The what's that thing from Tiger King right now? Hey, all you cool cats and kittens.
Oh yeah.
No. If you got any funny suggestions or anything you want to hear me say, I could be pure Canadian, do the Bob and Doug thing if you like. But let's get started. So one of the last questions we got during the week was, and let me just get the email on my other screen here, from Rick McAllister. Okay, so I think Rick is here today. Yes, he is. So Rick's question was, could you explain the difference between polar and Cartesian coordinate type systems in the sessions? So yes, we can. So I've got a mill turn part here, and I've got a pocket for that hex in the middle there, and I've done it basically the exact same way. The only difference between the two is Rick's question, which is in the motion control section, if you have the box checked for fourth axis, if you generate it as polar, or if I open the other one up, Cartesian. So they're the exact same toolpath. And if you look at the wireframes, they're exactly the same, pretty much. The only difference is what that Cartesian versus polar actually means. So what I've done is I got two whiteboards, and hopefully these pop back up. Perfect. Okay. So Cartesian is what you're familiar with. This is what the Cartesian coordinate system is what we refer to when we talk about X, Y, and Z. And what that specifically means is a point somewhere in this 3D space, let's say that guy right there, can be defined as being on an X coordinate, a Y coordinate, let's try and draw like that, and then a Z coordinate. So that point right there actually can be defined by having a position in the X, Y, and Z axis. That's literally what Cartesian is referring to. Now, if we go to, let's see, maybe I can jump back like this. I don't use whiteboard that often.
And just remember, everyone, we're machinists, we're not artists.
Yeah. That is a very good point. Now, some of this is pretty much already familiar with some people, but I'm just covering this just in case you weren't really familiar with polar versus Cartesian. So this is kind of really basic geometry sort of thing. In polar coordinate systems, basically is what you have here. So we have this kind of third angle projection here, and a point on this cone can be defined with 3 coordinates as well. But in this case, the 3 coordinates in a polar system is the X, the Z, and a C coordinate. C basically being, if I define a point, let's say right there, it has an X coordinate, but it also has an angle coordinate. Let's just draw my theta right there. There it is. Okay. So basically that is an angle around the rotary being the Z axis. And then also if we were to look at that same point on this screen, it would have an X coordinate, it would have the Z coordinate, and then from this point of view, it has that C coordinate, the rotation from whatever reference point. So basically what that refers to is on the other screen, you would have had X, Y, and Z as a coordinate. And for whatever reason that didn't draw. Oh, there it is. Okay. And then in this case, this point has an X, Z, and a C coordinate. So how does that relate to what we do in the software, what we do as machinists, like Kevin said? So let me minimize this. And it literally is this right here. So if I were to post out this one here, and I've actually posted it, so let me just open up that file. If you take a look at the G code from the polar, it has, like I said, X and Z coordinates all the way through. If we take a look at it in the Cartesian, it is just X, Y, Z, and that's pretty much it.
Yeah, so this is where, oh, sorry, go ahead. Well, I was going to say is this is where it comes in handy if you guys don't have much range on your Y axes for your mill turn. This is where it comes in handy for you.
Exactly, because you'll notice that there was no Y code in that one G code that we were looking at, because it's eliminated the Y. The Y doesn't exist in that coordinate system. Now you can, if you need to, generate it as, instead of an XC plane, let me open that up. Instead of an XC, you have the other coordinates there as well. So if you wanted to generate this as a YC or a ZC plane, if that would make sense for your setup. But all you're really doing here is, instead of having 4 coordinates, you only have the 3. So you either have X, Y, and Z, or X, Z, and C as in Charlie. And it's exactly like Kevin said. There are some machines out there that, even though they have live tooling, even though they are probably a full functional mill turn, they don't have any Y movement at all, or maybe it's so limited that if we were to do this corner right here of the hex, it doesn't have that much space for whatever reason. Now this is kind of a weak example, but you can imagine something that's a larger diameter can't really move all the way over here. So let's put this in a machine sim, and we can actually see the differences between the two. So let's start with something we're familiar with. So let's go with the Cartesian. I'll bring up a machine simulation. Okay, so there's our raw stock, and there is our hex pocket. Now, it's already been done by the previous pocket, so that's why it's already been removed. But what we're showing here is the movement of the part and the head of the machine. Let me slow this down a little bit. If I press play, the part stays stationary, and the actual movement is X, Y, and Z of the tool. If we did this with polar, we're actually engaging the C axis. So like Kevin said, if there's no Y axis movement, we're just moving in X, Z, and C. So the same pocketing toolpath, same geometry, same tool selection. The only thing I changed was the selection of Cartesian versus polar. This is polar we're looking at right now. And if you look, all you're seeing is movements in the X and the Z direction. In some instances, that could actually be better, not only because of the work envelope you have available to you, let's say the lack of a Y-axis, but it almost is a little easier sometimes on the machine, depending on your machine. But that is literally the difference between polar and Cartesian. No matter the tool path, you have this option of either engaging the 4th axis like we see here, or just locking it in place and then just moving everything in the X, Y, Z coordinate systems. Does that make sense, Rick? That was your question. So is that what you're looking for?
Perfect.
Yes, yep. Perfect. All right, awesome. Okay.
And does that make sense for everybody else that's in here?
It was Rick's question, but it's for everybody.
Yeah, yes, it's for everybody. Rick, you don't get to have all the credit, or you don't get to steal the knowledge.
Awesome. Okay, so if there's any other questions on that, or how to best use those two options, one versus the other, when you should use it, you can always give us a call at the main tech line, or send us your part, and we can make that kind of a recommendation as well if you should do that. But that's literally what that's all about, just engaging the 4th axis or not, and it's just shifting the coordinate system that you're outputting the code in. So for the next question, this one actually comes from, guess who? It's Jake's question. Jake sent this question in. Let's go to our favorite part, the one that has all the stuff on it.
And Jake, don't take that the wrong way. We love these questions coming in.
No, absolutely. If it wasn't for Jake, we probably would just be feeding you guys topics. But yeah. I love the idea that there are questions out there, not because that you need the questions, but because this feeds into what we're trying to do here. And always remember that your question is probably somebody else's question. So never feel like you need to not ask the question. It's not, there's never a stupid question, because if you're thinking it, somebody else is thinking it as well. And for instance, I mean, that polar versus Cartesian thing, I had to remember exactly how to describe polar, because it makes sense when you just look at the G code, but to understand what that's all about, to take a look at it it's the basics that I had to remember. A lot of times we forget our basics, even though we get so advanced in what we do. But Jake's question was, let's get to the email and I'll read it out. Okay, so his question was relating to the target and machine stock comparison option in the solid verify simulation. So let's get something we can solid verify here.
And while Mark's doing that, both Mark and I cannot think for the life of us. So I think it was yesterday we talked about coming up talking about a different subject for today. And I asked you guys if that would be a subject that you guys would want to know more about, and you guys all wrote yes, but we can't remember what that subject was. So if anybody remembers that, I tried to go through and rewatch the video, but I didn't think of it till a couple of minutes before, and I can't think for the life of me, and Mark can't think of it. So
yeah, and there's actually a transcript that gets saved from these things, but I think it's only the chat log. So all I saw was my email. Yeah, okay. So there's no question, no recovery of the question.
Maybe I was thinking the day before when you're talking about tools and doing shape tools, but I can't.
It might have been. It might have been because I remember that conversation where we could talk about shape tools. Okay, so I just needed to put my material in there. For whatever reason, it lost it, and it thinks it's missing there as well. Let's just choose one of the default materials.
And Jake, I want to see some of your other team members in here as well.
There we go. Okay, so we're going to calculate this as whatever material I just chose at random. Okay, so what I'm doing here is I'm just updating this solid because for whatever reason, I think we kind of maybe made a change to those 3DI machinings and whatnot. But what I want to do is I want to get some toolpaths on screen and we can do a solid verify and then we can do the stock and target comparison. The specific question was, even though he set, this is Jake's email, even though he set a 0 offset on his HSM toolpath, he still saw some red and orange coloring. Now, if you remember that little interval of colors, the red and orange would be a gouge. And if he saw some red and orange, the first thing we would ask is, what is your facet tolerance set to? Because if you remember, the STLs that get built in the background are actually built by these little triangles in the STL file called facets. And when you set your facet tolerance, you're actually setting the size of each of those triangles. So in that stock and target comparison, if you have a level of, let's say, if you remember mine, it was set to, I think like 4/10 and then 4 thou on the negative side. But we are measuring with facets that are 50 thou. There's no way that we're going to get something as detailed as 4/10 if we're measuring it with building blocks that are 50 thou in size. So that red and green, that red and orange color could simply be that the facet has been flipped 180, because that's literally what those facets are. They're either in one direction or another. So you always got to remember that your facets are either tighter or as tight as your target and machine stock comparison. And I didn't think this one would take that long to calculate, but basically, let's see if I can kind of get a screen grab of something on this side. So we can at least show on screen what we're talking about. So this guy right here. So this is the stock and target comparison that you see in your solid verify. And as you can see from the screen grab, the lower end here starts at 4/10 and then 4 thou. So if there's a gouge of 4/10, it'll be colored orange. If there's a gouge of between 4/10 and 4 thou, it'll be actually it's the other way around. So between 0 and 4/10 it's yellow, 4/10 and 4 thou is orange, and then anything more than 4 thou is red. So indicating a gouge.
Remember, guys, you can set these up to the numbers of whatever that you would like, and they'll stay in there for you. So technically, or what I do is, just because you get, like Mark's talking about here, we got two different tolerances going against each other. You got the tolerance of the solid verify, and then you have the tolerance right here in your stock target comparison. So what I'll do for the good number, the yellow in this case, I would put 1/10 in there, and then the orange I would put that at 1 thou, and then my red I would put that at 5 thou. That way, when I go to do my solid verify, I don't have to have a 4/10 accuracy to play that through, because it's just going to take up a lot of time to create that model. So
absolutely, yeah. It's a matter of the accuracy that you're looking for. So it's kind of like something that Kevin and I talked about earlier this week. If you need to keep to a certain tolerance, then just worry about that tolerance. If you make it too tight, then you're waiting for that STL to be built using that facet in the background. It's going to take forever to build. Whereas if you really just care about a certain tolerance, then just set that as your facet, and then you'll be able to analyze to that level. There's a customer that we have that does these rather large parts. and they're basically feed screws. So they have these helical groove through them and other notches through them and whatnot. If you've ever seen a feed screw, these things are huge. And in order to solid verify that, he keeps his tolerance very coarse. I think we advise them to maybe keep it at 50 thou or 100 thou, only because of just how big the thing is. So rather than render that thing right down to 4/10 or a thou or whatever, you just keep it super coarse. You can check what you need to check, and then you've got your solid verify results. You can confirm at least you're not going to gouge to a certain level. But to the fine details, there is things inside the solid verify where you can kind of reduce your interest to a certain area. You can kind of tighten it up if you need to. But overall, it's like Kevin said, if you're really just interested in 100 thou, then just set these as increments of 100 thou. The only thing I would say is on this range here and here, just around the 0, maybe not on the plus side, but definitely on the negative side, this at minimum should be the size of your facet. You want this to be seen as either a flip up or a flip down, because if you make this anything smaller than your current facet, then this guy's not really going to tell you anything, because you could have that facet flipping in the wrong direction, indicating a gouge when it's not really a gouge. If anything, make this lower and make this one your actual size of your facet. That way you can at least get some accuracy on this side than this side. But it's a matter of what it is you're trying to get out of the solid verify. So to Jake's question, he might have set to a 0 offset on whatever toolpath he's doing, the HSM finishing toolpath. But if his facets were set to coarse, then it's indicating a gouge where there probably is not one. And these radio buttons up here, since this is a screen grab, I can't really change it, but this actually changes the range as well. So in this case, you can see that the 4 thou is grayed out because the radio button above this one is the one that's turned on. So he's really only checking up to that level. If this one was checked, then he would check to that level as well. You'd have 2 levels of plus side checking going on here.
And what I've seen, to simplify it, for some people, what they'll do is they'll actually do like what Jake did here. Is he's only got 1 on the plus side, he's got 1 for the good one, and then the customer would have 1 on the negative side, so you're not having to check such a wide range.
Absolutely. I mean, if you're really just checking to make sure if there's any kind of gouge, then you can just check this radio button here and only check for 1 negative. If there's more than that 1, then it's a gouge no matter what. So if there's a gouge of 4 thou here, I don't really care how much bigger that gouge is, because it's already a gouge that I need to take care of. So you can really shrink that down and reduce the amount of colors you see, because a lot of times what you'll get as well, because of that faceting, because that level of accuracy, sometimes you'll get like a 2-tone kind of color. And in that case, it's just because the facets are flipped up and down, whatever. So there's just a spread of different inaccuracies or accuracies, depending how you look at it. So if you looked at one color, you know what it is. So like Kevin said, you might just want to reduce it by clicking that radio button. And if it's more than a certain negative, then that counts as a gouge. You have to address it regardless. And we're taking this whole class just for me to calculate this thing. All right.
I think we should have grabbed a different part.
Well, the theme of this week was this part. So, but this will really show off the gouging, not the hopefully not the gouging, but this will really show off the different colors, because this 3D eye machining is going to leave some scallops. So we'll actually see some portions that probably have more material than less material. And that basically is what this guy's all about. We can see the plus side, and then if we had any kind of negatives, we would see the negative as well. But that's basically what that is all about. It just compares the stock to the machine, or sorry, the target to the machine stock. So the updated stock based off all the toolpaths that you've already provided. And then the colors can be ranged by the numbers you plug in there and actually what button you click on. So Jake, does that answer your question? Do you want to go actually into Solid Verify to see how that works, or does that pretty much answer the question? Okay. To anyone else, because again, this is for everybody. Does anyone else want that to be kind of fleshed out a little more inside the Solid Verify?
And you guys do have this option in Solid Verify as well as the SolidCAM Beta simulator too. And for those of you guys that don't know about the SolidCAM Beta simulator, what that is it's beta, but the only reason we're labeling it as beta right now is because each build that we come out with is improvements and features that have been added in there. So with this new beta one, like I think we talked about earlier this week, you can do a partial zoom feature in there. So like I said, each one of those you can keep adding in there, and it will actually get to a point where that will be your main go-to.
And it does have a lot of cool features in it. If you haven't seen, I don't know if it was the subject of a CADCAM before. Did you ever show it in CADCAM, the beta?
I think I did, but we'll actually be covering it in the CADCAM What's New 2020 for the simulator.
Oh yeah.
Just because there's been so many new features that have been enhanced in there.
Okay. Well, I'm gonna let this calculate anyway because I want to. But the answer to Jake's question, I didn't read the rest of the email, but yeah, he's asking it now. What are the difference between OK, execute, even cancel, and the X? So the answer is, if you click OK, you're not really engaging this. You're just kind of saying, yeah, okay, those numbers are okay, the levels are okay, it'll just get you out of there. Execute actually executes this option. So when you click execute, it actually will analyze the part and show the colors and the ranges. That's basically what execute does. OK is just, yeah, okay, close this out.
OK is accepting it and saving out those settings. So when you go to reopen that again, it will have the same results that you had or same values that you had in there from previously.
Exactly. And the opposite of that is if you want to return to what the defaults are, that's the default button. Cancel versus X, I think they do the same thing. It's just cancel, don't save what you've done here, just get out of this window, and X, basically the same thing. Yeah. And
you guys can change those colors to whatever colors you want. I prefer, red to be gouge, orange to somewhat gouge, green as good, and then yellow as material left over, and you can pick a purple or something like that, or a blue. But whatever you guys would like, you can definitely have that in there.
Yeah. And that button right there, that color is the button. So you would click on that, it brings up the color wheel or the color grid or whatever, and then you can just choose your color, just like Kevin was saying. Why so long this took.
Any other questions, guys? See a lot of good ones coming in here, so. Don't see anything else. Dave, if you got to suffer working with Jake, you got to have something. All right, so, well, I think with that being said, kind of wraps up for everything with the questions that we had. So kind of covering the stock target comparison in the Solid Verify, as well as the polar versus Cartesian. And I know that polar versus Cartesian gets a lot of people mixed up, but if, like Mark said, if you guys do have more questions into it, definitely give us a call on the support line. But hopefully this was a good representation of showing you when you should be using Cartesian versus polar.
What about stock replacement? Oh, okay, that was an email that we got from Jake regarding stock replacement. There's a short answer. Basically, well, I mean, yes, we'll cover that for another day because I'd like to give you a fleshed out answer on that one. But the really short answer is what he was asking was, if he doesn't know what size of stock he is going to eventually use, should he just program with the size of stock that he's just kind of planning to? And then when he gets to the actual shop and then he actually sees what size of stock he has, I would say you can program for whatever size of stock you imagine you're going to use, because remember, a lot of our toolpaths now are stock recognition. So when you do actually find out the size of your stock, you can change it, either change your box definition, or if it's a 3D model, remember that 3D models are associative, so you can change the 3D model to represent the true size of the stock, save and recalculate, synchronize, whatever you're going to do, and then your stock recognition toolpaths will automatically update themselves. So you can always adjust the stock before you G-code the toolpath.
Yeah, we can definitely show that too. And too, I mean, when you guys first start out, we see this every once in a while with some customers that are very new to the product, is they'll program their entire part and then they want to move their coordinate system around, which is fine. But try to get that coordinate system in the right position before you start programming all your operations, because if you go through and in Mark's list right here and change a completely different levels, location, something like that with that coordinate system, what will actually happen is some of the operations will become out of sync, and you'll just have to refine some of those levels going through there. So just kind of.
The reason I brought this up is because exactly what Kevin's talking about. So in this coordinate system, that point has a certain X, Y, and Z. But if you change your coordinate system around, let's say we said that the toolpath is on that level there. If you change your coordinate system completely, let's say you move it around or whatever, now on this new cube, and I'm going to draw a cube real fast. There it is. That's my cube. If that thing is, let's say, whatever distance this is now, let's see, the origin over there to there, let's say that is, whoop, that is another inch in difference. Now that toolpath thinks it's supposed to be, let's say, 1 inch above 0. If 1 inch above 0 is now shifted by 1 inch, this thing is now 2 inches above 0 because you've changed the reference point. So if you set your coordinate system to start, you'll be good. But as soon as you start shifting it around, you're shifting everything about that toolpath. So you'll change levels, you'll change locations. So if we're doing a toolpath over here, well, now on this new cube, this is probably way out in space or something like that. So always make sure that you want to kind of just confirm that coordinate system up front. Like Kevin says, you can actually change it. You have the ability to change it. You can change locations, even change orientations. But just remember that that's going to fundamentally change the reference points of all your geometries, your tool paths, offsets. A lot of stuff can be upset by the change of a coordinate system.
Perfect.
Okay, so like Kevin said, if there are any other questions, you can always email me. And this is always the challenge of the SolidCAM Live because I never type out my own email. One day I'll get faster at this. And there it is. You can email me directly for topics for the SolidCAM Live sessions. You can email me for training. Remember that this is a 30-minute example of the kind of one-on-one training we do, but if you are interested in getting one-on-one training yourselves, contact your local salesperson, get them to get you a quote on some hours online. You can get it directly with me, with Kevin, with Greg, Paul, Scott, Eric, all of us on the team. We are all available in your time zone to help you with your parts directly or with your questions directly. In addition to that, remember that if you know anybody that could benefit from the use of SolidCAM, there is finder fees available for that as well. So if you can get them into a demo, you can get them into a demo and then they eventually buy. There are certain percentages, certain fees that we would grant you for basically doing the sales work for us. Our sales guys, they are busy, but they can't get to everybody. So if you know somebody, then spread the word. This session will continue next week, every day at 2 p.m. Eastern time. If you're already registered, you should see the notifications, and if not, just go to the website. Make sure you've got the American flag on setting for your website that you're on, and then you should be able to re-register for next week's sessions. But yeah, so what we'll do is we'll end it now. This recording will also be available on YouTube after Kevin gets a chance to translate it and put it onto YouTube. And we'll talk to you guys on Monday.
All right. Thanks, everyone. Have a great weekend.